no solutions. That's what this tells us, okay? Okay, so we have no solutions here. In this example, it's a little, what do you call it, different. Mostly, so what's going to happen here is, just want to check the microphone was on. So here what we have is, again, from the first equation, 2x minus y equals 5, right? So from here, just like before, right, we can get y in terms of x, namely y equals 2x minus 5. We can do that. And then just like before, we substitute into the other equation. Right, we have 4x minus 2y equals 10. So here we substitute, we get 4x minus 2 times 2x minus 5 equals 10. So we have 4x minus 2 times 2x, that's minus 4x, minus 2 times minus 5, that's plus 10. And of course the 4x is canceled. So we get 10 equals 10. Well, here, of course, 10 equals 10. That's true no matter what the variables are, right? This is true no matter what. So that tells us we have infinitely many solutions here. We have infinitely many solutions here. So in this case, we had no solution, so the system was inconsistent. Here we have infinitely many, so the system is consistent. Those equations, though, are dependent. Or linearly dependent, same thing. All right. Are there any questions on this? Okay, so this one I was going to have everyone try because I let the other class try this one also. So I'm going to have to stop the recording. Wait, did it go? Oh, great. Let me stop the recording. Okay. So this is actually the substitution method. So again, we're going to solve this using that method. Okay. So from the first equation, right? I mean, this is what I did. I got y in terms of x. You could actually get x in terms of y if you want. Okay, you could. I mean, what I like to do is the variable that has a coefficient of 1. I like to get that. I like to get that in terms of the other variables. So here y has a coefficient of 1, so I like to get y in terms of x. I mean, x also has a coefficient of 1, so you could get x in terms of y, either one. But either way, we get y in terms of x, so we subtract x from both sides, right? And we get y equals 4 minus x, as you can see. From here, right? Again, once we know what y is in terms of x, again, we subtract x from both sides. Now we substitute into the other equation. What we get is 4x plus 2y equals 4x plus 2 times 4 minus x. Again, we got y in terms of x, so we substitute it. And now the second equation has 4x plus 2y equal to 6. So this is equal to 6. So this was repeated from this was the last step at the bottom. We have 4x plus 2 times 4 minus x. Well, that's 4x plus 8, 2 times 4 minus 2 times x, which is 4x plus 8 minus 2x. But that, of course, is 2x plus 8. So altogether, we have 2x plus 8 equals to 6. Right? And what's good about that? Well, we have one equation with only one unknown. Let's solve that. That's a lot easier to solve. Namely, we can subtract 8 from both sides, as you can see, right? Because we want to get x all alone. So we get 2x equals negative 2. And then, of course, we divide by 2 to get x equals negative 1. So now that we know what x is, can we get y? Well, yeah. Remember, we got y in terms of x, right? Y is 4 minus x. So y is 4 minus -1, which in this case is 4 minus -1, which is 5. So x is -1, we get y is 5. So now notice the system is consistent. There's only one solution, so the equations are independent. Are there any questions on this? Okay. Now another way to solve these, a system like this, excuse me, is graphing. We can solve a system of linear equations by graphing. Namely what you do, I mean, if you look at these equations, you should see that, yeah, these are going to be lines, right? Remember, the general form for the equation of a line is ax plus by equals c. You essentially have this also, just instead of a, you have d, instead of b, you have j, instead of c, you have k, but, they're constants. So the graphs of each of these are going to be lines. We can graph those. Any solution then, remember, to an equation is a point on the graph. Okay, so, but we want solutions to both equations here, right? We want solutions to both equations here. Hence, we want points of intersection. That's what we want here, points of intersection. So in other words, if we were to graph it, we want an ordered pair that satisfies both systems, that satisfies both equations, excuse me. In other words, we want a point that's on both lines. We want a point of intersection. If there is one, then the system is consistent. What can happen though is that the two lines could be parallel, which means they never intersect. In that case, there are no solutions and the system is inconsistent. Now, what can also happen is the two lines could actually coincide. They could be on top of each other. In that case, there are infinitely many points of intersection. That is, there are infinitely many solutions. So the equations then would be dependent. The system is consistent. When there are no solutions, it's inconsistent. That's when the lines are parallel. Sorry, went too fast. Now, here, as you can see, I'm reminding you how to get the Desmos, because you can graph these in Desmos. You go to the website. You might be logged in, you might not be, that's okay. You go to Math Tools, then you'll get a bunch of different calculators you can click on. You can click on Graphing Calculator. You'll end up in a screen like this. And then what you do is you enter equations so that you get something like this. Into these, I guess, text spaces, I'll call them. You enter equations that you want graphed. And you'll see them graphed, and you'll see that if there are any you'll see that if there aren't any solutions, excuse me. And again, you'll see if there are any points of intersection. Okay, that's what will happen. Okay. That's what we're looking for, right? Remember, we're looking for points of intersection. Okay, all right. Let me actually go through this as well, just to illustrate it. Okay, so let me do that. Okay, let me get the Desmos. All right, do So, oh wait, I haven't shared that. Let me share that though. Sorry. There we go. Okay. Well, let me just wait for it to show up. Ah, here it comes. Oh, no. Oh, for goodness sakes. Let me try again. Let me try again. Oh, what's wrong with this thing? There we go. Nice. All right. The internet doesn't always, I guess, act the way we want it to. So here, again, I'm here at that graphing screen, okay? So we can type in the equations here. So let me do that. So we have 3x plus y equals 10, right? We have this line. The other equation is 2x minus y equals 5. And you can see that they intersect at this point, 3, 1. We could zoom in also. We can use the zoom features here. You can click and drag. But you can see that they intersect at 3, 1. And that's their only point of intersection. Any questions on that? All right, let me let me get back to the notes then.